Hi guys. Today we're going to talk about concentrations of solutions. So when I think of a concentration of solution, I go back to my childhood and I think of making Kool-Aid, of putting a drink mix into water so that the water would taste better. My favorite flavor was fruit punch Kool-Aid. And if I had been particularly good, my mom would let me add extra sugar to it. It didn't even come with sugar in it. So let's talk about this for a second to review our vocabulary before we move on, right? So we have a big pitcher of water. I'm going to color code this, right? So we have our pitcher of water. All right, so our water is our solvent. And our solvent is what does the dissolving, right? So does the dissolving. And I like fruit punch flavored Kool-Aid, so I'm going to add red Kool-Aid here. I'm going to add red little dots, right? Okay, so those red dots are the solute. And that is what is being dissolved. So in our example here, we're going to use drink mix. And our solvent in this example, and very often, is water. Okay, so going back to talking about concentrations of solutions, when we have a concentrated solution, we have a large amount of solute dissolved in the solvent. So if I were to kind of draw a visual aid of this, all right, I would have a whole lot of solute, right? So a lot of solute compared to a tiny bit of solvent. All right. And a dilute solution we have right here is a small amount of solute compared to solvent. So if we were to keep going with this, we would say that we have a smaller amount of solute. We're reducing the solute and increasing the solvent. So that drink mix, that Kool-Aid back in the day, or Gatorade powder, or Mio, or Crystal Light, or whatever it is you enjoy as a drink mix, if we have that mix already dissolved in our solvent and we want to dilute it, we would add more water, right, to make it more dilute. In chemistry, we express concentration with the word molarity. So it means the same thing. When we talk about molarity in chemistry, we're talking about the concentration of a solute. And how we define it is moles of solute per liter of solution. So that is actually our formula. Let's go to the next slide here. So here is our formula for molarity. We have moles per liter. And this little triangle guy on the side is showing how we can rearrange the formula. So for solving for molarity, then we're going to take moles divided by liters. If we are, here, I'm going to erase that. If we are solving for moles, then we're going to do molarity times liter. And if we're solving for liters, there we go, solving for liters, then we are going to take moles and divide by molarity. So we'll always be given a piece of information, 2 pieces, and have to solve for another one. Okay, so let's say they don't give us moles. We know we can figure out moles from grams. If they give us the grams we have of something, we know that we can just convert that by using the molar mass. So we would have off the periodic table, right, grams per 1 mole, and do that conversion to get to the number of moles that we have right there. And liters, our big deal there is that we might have our solution given to us in milliliters. And the same thing, we know that there is 1,000 milliliters in 1 liter. And so we can convert that to liters pretty easily too. All right. Okay, to make a solution, we're going to start by taking a beaker. And let's say we want to end up with 100 milliliters of solution. What we're going to do is our first step is we're going to add a small amount of solvent. So step 1, add a little solvent. So that's step 1 right there. And then our next step is we're going to add the solute. I'm going to change colors there. We're going to add the solute to that and dissolve it. We might stir it. We might put a magnetic stir bar in there and put it on a stir plate. Whatever will get that stirred in. And then our last step, I'll use a different color here, is to add the rest of our solvent to bring this full amount to the final volume that we needed. Now the reason that we do that is that solute takes up space. It actually takes up volume. So if we were to just pour in solvent to the final volume that we wanted, like 100 milliliters or 0.1 liters, and then we add that solute, our volume would actually be over that 0.1 liters. We would have too much volume, and it actually would not be the right concentration. So that's why we dissolve the solute in a little bit of solvent and then bring it up to the final volume so that our calculations are correct. All right, talking about calculations, let's do a couple of examples. So here we have calculate the molarity of a solution containing 0.915 moles of hydrochloric acid in 150 milliliters of water. So we're calculating molarity. So we are going to divide moles by liter. All right. Our formula outside of this triangle is moles per liter. All right, so we are in moles here, but this guy, 150 milliliters, we need to convert that. So 150 milliliters, we're going to divide by 1,000 milliliters per 1 liter. So that means we have 0.150 liters. All right, so there's our formula. We're going to divide moles by liters, and we end up with a molarity of 6.10. And our unit is a capital 1, or we could write moles per liter. But I think you'll agree writing a capital M is much easier than writing moles per liter. All right, let's do one more example here. Here we have how many grams of sulfuric acid would be required to prepare 500 milliliters of a 0.6 molar solution. Okay, so this one we have to rearrange our formula so that we have moles by itself. We're solving for moles, and we're going to take molarity times volume. So whether you take the formula and rearrange it, or you remember, here, let's go back for a second, this pyramid here, right? We're solving for moles, so we're multiplying molarity times liters. And then we're going to pop in our information. We do have one conversion here, right? 500 milliliters divided by 1,000 milliliters per 1 liter gives us 0.5 liters. So we're going to have our molarity times our volume, and that's going to give us 0.3 moles. Now it asks us for grams, so we have to get the molar mass of sulfuric acid, which is 98.09 grams per mole. And so here I'm going to draw it out a way that we're familiar with in class. If we have 3.0 moles, right, we want 1 mole down here, and we want 98.09 grams up here. So this is our molar mass of sulfuric acid, H2SO4. And when we multiply this guy, we get 29 grams. That's how much we need of sulfuric acid. Oops, I should write that too. Be totally thorough. To get a 0.6 molar solution that is half a liter big total. All right, and how I would do that is I would take a little bit of water. I would dissolve these 29 grams of H2SO4 in that amount of water, and then I would add the rest of the water to bring the total volume of my solution to 0.5 liters. All right, thanks guys.